Happy Safari Day, grade 9. I'm going to make a short video going through your quiz to help you with review for your next test. F equals 1 upon t. So here I have three formulas that I'm going to use to help me solve problems in this quiz. The wave equation, which is v, velocity, equals f lambda. F is frequency, lambda is wavelength, the length of one wave. We have v equals d upon t, which is the relationship between speed and time, distance. And f equals 1 upon t, which is the relationship between the amount of waves per second, which is frequency, and the time it takes for one complete wave oscillation, which is t. Okay, that is my three formulas. Okay, looking down at the first question. Ian whistles into a microphone attached to a computer that draws a picture of the wave. Right, there's my wave. Okay. So what is the amplitude? So here's the amplitude here, not very big. And wavelength is from one wave to another wave. So there's my wavelength. Right, he now whistles a quieter note of a lower frequency. So if it is a quieter note, it will be a smaller amplitude. If it's a lower frequency, it will stretch out because the wavelength will get bigger. There's less waves per second. So which wave looks like that? Okay, the answer is E. Look, there's a lower amplitude and the wave's stretched out. There's less waves per second. Alright. Waves, now number 2. Water waves of frequency 3 Hz are travelling at 3 Hz are travelling at 4 meters per second. So what information do I have? I have a frequency equals 3 Hz. I have a speed v equals 4 meters per second. Right, I'm looking for a wavelength. Do I have a formula that relates all three? By Jove, I do. V equals f lambda. But I'm looking for wavelength, and that's not quite how the formula needs to be. So I need to take frequency, and if it's multiplying here, it needs to be dividing over there. So wavelength equals v divided by f. V is 4, f is 3. So 4 divided by 3 is 1.33. On to the next question. Okay, here's my diagram. I've got 12 meters from here to here. Calculate the wavelength of the waves shown. Well, I've got this distance of 12 meters and I want to work out how many waves are in this distance. So I'm going to count my waves. So a wavelength is any two similar points, peak to peak, trough to trough, whatever. So I'm going to count. There's one wave, peak to peak. There's two waves, peak to peak. 3 waves, 4 waves. Okay. Oops. Edit. Undo. If there are, why is it doing that? 4 waves in 12 meters. How long is one wave? Well, one wave will be 12 divided by 4, which equals 3 meters. If the waves took 6 seconds to travel this distance, so that is to travel one wavelength, what is their frequency? Okay, so the distance to travel one wavelength is called the period. The period is 6 seconds. So therefore, F equals 1 upon t. Sort that out. F equals 1 divided by 6, which equals, I can't do that in my head, it's too hard, about 0.16, something like that. Yes. Okay, use the wave equation to calculate the speed of the waves. Okay, wave equation is this, v equals f lambda. What is my f? F is 0.16. lambda I've just worked out is 3. So V equals F, substitute in 0.16 times my wavelength, 3. So V equals 0.5 meters per second. Alright, you see a flash of lightning, and then hear the thunder 6 seconds later. Okay, so I have a time. Seconds. How far away roughly is the thunderstorm? Right, I have a speed. V equals 340 meters per second, and I'm looking for a distance. Do I have a relationship that relates velocity, time, and distance? By Jove, I do. V equals d upon t. But I'm looking for d. So t is dividing here, so it needs to be multiplying here. So d equals v times t. D equals v, which is 340, times my time, which is 6. So my total distance is 2040 unit meters. Last question. A boy, I'll draw a little picture of a boy with very strange arms, is standing 500 meters away from a wall. This is not drawn to scale. Okay, so he is 500 meters away. He plays a note of 600 hertz. Okay, so I have a frequency F equals 600 hertz, which travels at a speed of 330 meters per second. Alright, I have a speed 330. How long before he hears the echo off the wall? Right, so I'm looking for a time. So the echo is going to go from his mouth, making a noise. It's going to have to travel all the way to here. It's an echo, so it'll bounce back. Bounces back. So the total distance that the note will travel will be 500 meters here, then 500 meters back before he hears it, which means my total distance is 500 plus 500, 1000 meters. So I'm trying to work out the time it takes for the note to go from here, then back. Alright, so frequency doesn't really affect the speed of a wave, it's just how many times it happens per second. So I'm going to use my formula, V equals d upon t. I'm looking for t though, to get t up here. So if t is dividing here, it needs to be multiplying here. So t v equals d. And if this is multiplying, it needs to be dividing here. So t equals d divided by v. What was my distance? Total distance for the echo to go there and back is 1000. What was my time, speed of sound? My handwriting is shocking. Don't ever let me criticise you for handwriting. 340, so my time ends up being about 3 seconds. Oh, it's not 340, it's 330, I'm a half-wit. About 3 seconds. There you go, job done.